My name is Chris Bean and I'm Senior Professor of Geophysics at the Dublin Institute for Advanced Studies. This evening I'm giving a lecture on uncertainty in Earth systems in terms of earthquakes, volcanoes, climate change. So it's a general discourse on predictability in Earth systems. One of the first things I'm hoping to get from the talk is that people might get an understanding of how the Earth interacts in its totality. We normally think about the atmosphere, the solid Earth, the oceans, and sometimes we think of these things as being quite separate. But really they're all interacting in what we call the Earth system, and there's an interplay between all of these different components. Then we want to look at the difference between prediction and forecasting. We have a tendency to think that science is going to help us to predict things, and that's not always the case, to be able to say with exact precision what's going to happen if we do A, B, or C, or will there be an earthquake here tomorrow at 3 o'clock, for example. We're not able to answer questions like that. But we are able to forecast, analogous to the way the weather forecaster forecasts the weather. We are able to make some forecasts about some very complicated things that happen in the Earth, volcanic eruptions, earthquakes, landslides, and so on. But we're not able to make exact predictions. So I wanted to draw the distinction between prediction and forecasting, and what can we then do with forecasting once we know what the likelihood is that something will happen. How do we actually deal with that? And the final thing I'd like to talk about is how the use of technology and artificial intelligence is poised to significantly reduce the risk to human life and property through a methodology called advanced warning or early warning. In an early warning system, the process that we're concerned about is already at play, and we may have seconds to minutes and possibly hours to do something about it, but we're actually measuring the system once it started. For example, it could be a distal flood. It could be a very far away earthquake that is going to have some effect, small effect locally. It could be the beginnings of a volcanic eruption. You might have an hour to do something. With a highly trained society with respect to how to respond, one can do a lot in a very short length of time. And this is a key kind of melding of technology, artificial intelligence, proper engagement with social authorities that can reduce the risks to society associated with natural hazards. I'm absolutely delighted to have been given the opportunity by the Academy to give this discourse. I think this discourse program is really, really interesting. I mean, to engage with the public in terms of what science means, how it works, and what its outcomes are, I think is extremely important. And to have a vehicle for that here in the Academy, that's really well structured and well honed. I think it's a really great program. So I'm really, really happy to be here. I'm delighted to have the opportunity. I'm very grateful to the Academy for giving it to me, and I'm really looking forward to giving my presentation later on.